In this tutorial, you will learn how to make a helical gear from a drawing by learning how to scale sketches effectively, use joints to fully control different components, loft to create our desired shape, use the circular pattern tool, create sketches using diameter dimensions, revolve our sketch, and create a simple gear pattern. Welcome to the Learn It channel. Let's make a complex helical gear. So the first thing we're going to do is make sure to save our project. And we're going to call this helical gear. So throughout this tutorial, I'm going to show you that sometimes within Fusion, we hit some snags. We hit some obstacles or limitations, and we have to work to overcome them. That's just part of CAD design. We have to work with the software that we have and deal with problems as they arise. So let's get into it. Let's first of all create a sketch. And we're going to create it on our YZ plane. Now, our document settings, we're going to switch on over to millimeter. So remember, all our drawings can be found on our Patreon page. Link is in the description below. And this is for all members, whether paid or free. So let's get into it. We are going to create a sketch, and we're going to start with our overall diameter. Very good. So let's just move that on over. What I like to do is place the dimensions in the same location as where they're found on the drawing. And that just makes it very easy when we're referencing the drawing, that we can look at the drawing, we can know exactly where it is on our sketch that we're creating in a CAD environment as well. Great, so let's create this inside circle as well. And this is 107 mils. Perfect. So let's zoom on in there, and this 107 is off to the side. Perfect. So now what we can do is let's create a center line, and remember to change this to a construction line. We single click, and also recognize I'm pressing escape a bunch of times. That's because once I maybe select a feature and then I go to, do something else, I have to exit out of any background operations, and I do that by pressing escape. I've mentioned this before in other tutorials. I basically rest my hand on the escape key on my keyboard because I use it all the time. Anyways, let's single click on that line and press X to turn it into a construction line. We can also do that over here. Very good. So now we've got this 3-point arc, and we are going to do something like this. We don't have to worry too much about the dimensions at this point, but I want to show you a little trick. And this helps sometimes. It's probably not the best use case right now, but what we can do is press D for dimension. We can also select sketch dimension up here on our toolbar, but I can pick this and go to our center line. And remember, once I pick those two entities, I'm just placing my dimension right now. So I'm going to place the dimension right on over here. And I could go like this. I could go 15 divided by 2. Our drawing says 15 millimeters. I could do the math right here. That's no problem. But sometimes it's not the best tool to use. And what I mean by that is humans are imperfect and we make mistakes all the time. So how can we mitigate mistakes? Well, there's different tools within Fusion to help us to avoid making mistakes. And so one of the things that we can do is press D, and we're going to create what's called a diameter dimension. Now, even though this isn't a diameter, you'll see in a moment what this does. So I can pick the center line, and then I can pick the endpoint here. Now, before I click to place my dimension, I'm going to right click, and let's go diameter dimension. And you see here, it places a dimension to an imaginary point over here, which is 15 millimeters. And it is symmetric to this line of symmetry, this center line right here. And we can put in 15. Now we might be saying, well, that's the exact same dimension as 15 divided by 2 when we go to the center line. And yes, that is true. But one of the reasons why we use this tool is because, again, when we're referencing our drawing, we want to make sure that this dimension is the exact same. And this is just to make sure that we are creating the correct dimension within our sketch. Sometimes we make a mistake. And of course, this is an easy dimension, but sometimes we create a dimension that is quite difficult or is an equation? Well, it's very easy to put a decimal in the wrong place or to put the wrong number in or something like that, especially when we're moving fast. So now by having 15 here, I look at my drawing and it too says 15. Now this is just one way of doing it, but what we could actually do here is I'm going to just press delete on my keyboard and we're going to go mirror. So let's pick this and we pick our mirror line as being our center line. Let's go OK. And this does the same thing because they're symmetrical now. So I can just pick these two endpoints and call it 15. And we've done the exact same thing as our other example just moments ago. Okay, very good. So you can see here too that our arc goes a little bit crazy when we move it too much. But anyways, let's just constrain it or put some dimensions on it as soon as possible. So there we go. I'm going to pick those two endpoints and we're going to go 40 mil right there. And we also have an arc dimension. So I'm going to place this over here and this arc is 82. And in fact, the drawing shows the arc dimension off on the left here. So again, I'm going to follow my drawing. It makes a whole lot more sense. And again, we can reference it with our eyes very easily. I could even put the 15 right there, the 40 right there. They're in approximately the same location as my drawing. So there we go. We've got this first tooth of our helical gear. So let's finish our sketch. Now, we can see that we run into some limitations already. And let me prove it to you. The drawing says that we have to create the same profile. We're going to move on over 50 mils. And as we move over 50 mils, this next profile is 75% of this profile. So how do we end up scaling a sketch? Well, we could go right into sketch and I could go to scale. So if we go to modify and sketch scale, that's one way. Some of you might find it really difficult to find certain tools, or I might be going a little bit fast in some of my more advanced tutorials. And you say, where was that? I don't know where to find that tool. Well, remember this secret. Just press S on your keyboard and look at this. We've got sketch shortcuts and then you can just type in scale. And there we go. We've got solid scale, mesh scale, and we've got sketch scale. So again, if I say something and I don't necessarily point it out right away or it's not clear, just press S and that brings up your search box. Anyways, what I can do is I can grab all these entities right here and I want to scale this 75%. I pick my point or my point and midpoint to scale. And as soon as I do that, look what happens. All my dimensions disappear. My scale disappear or my scale changes everything. So I don't want to do that. That is not what we want. Well, I can go finish sketch, and here's another thing that I could do. I can offset this plane, and I could go over, 50 mils, according to our drawing. Perfect. And I could create another sketch on this plane. I could press P for project, and I can select all this geometry. It projects it to that new sketch plane. And let's just hide the first sketch over here. And now, can I scale this sketch? Let's go, scale right here. Can I do it? No, we can't scale a projected geometry. So what do we need to do? Well, I'm just going to finish this sketch and I'm going to delete that sketch that I just created. And let's delete the construction plane as well. So we only have this original sketch. Remember, we can double click or right click edit. So how do we work around this? How do we take a sketch and how do we scale it? How do we manipulate it so it's exactly what we want? Well, I'm going to do something that's a little bit interesting, and it's one technique that you can use. It might not be the perfect technique or the technique that you prefer, but it's just something new. It's a workaround. If you have a better technique, drop a comment in the comment section below. We'd love to hear about your workflow, how you would figure out this particular problem. So anyways, I'm going to go finish sketch. Let's bring back the sketch. Remember, we can expand sketches. I'm going to make it visible. And what I'm going to do is I'm going to extrude it. And I'm going to go like this. I'm going to pick those two closed profiles and I'm just going to drop a value. It doesn't really matter what this value is. I'm going to go -10 and I'm going to create a new body. Now we've got this extruded figure right here. This is looking great. And what I can do now is I can scale this. Let's do it. let's press S like I just showed you moments ago, and we're going to type in scale. Scale sketch goes away because we're not in the sketch environment. So anyways, let's go to scale. We're going to pick this entity, and we are going to pick our point. It wants to pick this point off to the side right now, which is no good. We need to pick the center point of this to scale it properly. Remember, if I just move this right here, it will scale it about that point. So I don't want to do that. I want to scale it about the center point. So I'm going to go over here and I'm going to turn on the origin, and I'm going to select this as my point. And now as I bring this down at a factor of 0.75 or 75% of the first, I've got this body that's now scaled. But if I go to my bodies, I've got this only one body. So what happened to the original body? Well, it's gone. So anyways, let's go to our scale in our timeline, and I'm just going to delete that. Again, just press delete on your keyboard. Right click delete also works. It's just an extra step. Sometimes it creates some issues. So if you're finding that it does, just hit delete on your keyboard. It's very simple, very simple. Okay, let's hide the origin. Now let's do something like this. Let's go to the move copy command. We could also go over to body and go right click, and we can go copy, and we can go right click, and we can go paste. It does the same thing. It brings up, you see over here, move copy. Well, it does the same thing. We could move this on over to 50 mils. And now let's see what kind of snag we hit. So let's go S for design shortcuts. Let's go scale. We can pick this body right here, and let's try and pick the center point. So as I do that and I activate the origin, the origin is over here, and look at how it's scaling. This is not good either. It adjusts it in our x-axis. So this is no good. Let's do the workaround. So I am going to delete the move command. I've still got our copied body. You can see body 1 is our original body. And then I copied it, remember, by right clicking, copy, and then I can paste it. I've got body 2. So let's scale it before we move it. So S for search. We can go scale body. We can pick this. Perfect. Turn on our origin, and our midpoint is right here. This is looking great. So I'm going to scale this 0.75. And now let's move it. Let's go copy move. And we're going to pick body 2. We can just select it on the screen. We could also pick our, our midpoint right there. That works as well. And now I can move it over to 50 mils. Great. I can also angle it right now. Let's angle it. It's supposed to go 15 degrees. So I can go OK. And now look at what we have. We've got body 1 and body 2. Body 2 is out 50 mil and it's rotated 15 degrees. So this is great. However, we've already run into a snag, and let me explain what it is and how to fix it. So here's the snag. If we go back to our move command in our timeline, and again, I'm going to mention this. I mentioned it 100 times in all my other tutorials. I'm going to mention it again, is we can double click it, but sometimes that doesn't work. Sometimes the mouse is old. Sometimes it doesn't work because of a slow processor or something like that. So another method is right click, edit. And we'll say edit whatever, edit feature, edit extrude, edit whatever this tool is. So right click edit, sometimes that is easier. Anyways, once we do, you can see that the parameters that we put in, the calculations or the dimensions that we put in, no longer exist. In this instance, it's easy to remember because we know what we've just done, 50 mil, we've rotated it 15 degrees. This is very easy to remember, but picture that we have 100 different sketch elements or 100 different extrudes or 100 different types of moves that we've made. Well, this can be quite difficult to remember everything that we've done. So is there a better way? Yes, there is a better way. So instead of using move, which doesn't retain our dimensions, we're going to use joints. And in order to use joints, we have to use components. So right now, if I try and join one body to the next, you can see it has no components in our design. So we have to use components rather than bodies. So let's do that. Let's go OK. I'm going to delete everything I just did. So just go to your timeline. I can delete one at a time. Remember, just hit the delete key on your keyboard. It's as simple as that. And what I'm going to do is delete this extrude as well. The reason is because I'd like to turn this into a component, and I want to show you how to do that while you extrude. So remember, I could also go like this to bodies and go create components from bodies, and this will create a component. And you can see in the timeline we have an extrude, and this means that we've created a component from a body. I'm just going to delete that. I'm going to delete the extrude. Let's make the sketch visible again. I'm going to hide the origin because it's kind of getting in my way. And now let's extrude this. Very good. We're going to extrude it to 10 mil. And now for our operation, let's create a new component instead of a new body. And we've got this. So look at this. We've created a new component. We've extruded. So kind of looks like the same thing, but the workflow is a little bit different. You can see we've created a sketch, master sketch. We've created this component, and then we've extruded it. So this is looking great. Now I'm just going to rename some of these. So let's go to our sketch, and we're going to go to our helical gear profile. And then component 2, it's renamed it component 2 because we've created a component in our history already, even though we deleted it. So I'm going to go here, and I'm going to go to helical gear 100. And this is going to be our ratio, our scale factor. Okay, very good. Now let's hide this sketch. And what we're going to do is we're going to copy this component. So right click, we're going to go copy, and then go up to our top level component or our master assembly up here, right click, and we're going to go paste new, paste new. Why do we go paste new? Well, we're going to edit it. If we were to simply paste it, then anything we do to component 2 would be automatically updated to component 1. Actually, let's prove it to you. I'm going to go paste. I'm going to move this on over, and look what happens. If I go OK, and if I want to adjust something over on this component, let's go scale. I'm going to pick this, and I'm going to just keep the point right there. Look at both of them move because they're copies of each other. They're exact copies of each other. So I don't want to do that. I'm going to go back in time. Let's just go undo this time. Very good. And you can see we've got a paste. Remember, this is a paste, not a paste new. So I'm going to delete this as well. Now let's go back to helical gear, right click, copy, go to our top level component or master assembly here, and we're going to go paste new. So what that means is it's taken all the entities, all the tools that we've created so far, and it will retain those. But anything from this point, anything downstream, will not be reflected in the original component. So now we've got a whole different body, and I'm just going to move it off all the way over here. Doesn't really matter the dimension. Remember, we're in move copy, so it won't retain this value anyways. And in fact, when I go OK, you can see that it brings up this capture position and revert position. So this frustrates ones because before we move on, sometimes it brings up an alarm saying, do you want to capture this position or do you want to revert? This just means we've placed it somewhere. We could just move it around as well. Well, do we want to capture it exactly where this is? Or do we want to revert it back to its original position? Well, we want to do neither right now. Let's adjust our entity or our component. So at this point, look what I'm going to do. I'm going to go scale, and we can scale this. We can pick our midpoint. And this is the cool thing, is that under our new helical gear component, we can expand it, and it's got its own origin. So look at this. We can pick the origin for the point of scaling. So let's bring this down to 0.75. Let's go enter. We can hide that origin. Now let's use joints. And as you see, as we create a joint, this capture and revert position will go away. So anyways, let's do that. Let's pick our midpoint of this. And I'm actually going to pick the midpoint of this as well, even though it assumes that we want to mate these two together and want to flip it so that one is inside the other. And I'm going to move this on over now to the 50, and I'm going to rotate this 15 degrees right there. Now this is the thing about joints. I'm going to go OK. Now if we want to adjust this joint, let's go to our timeline, double click or right click edit, and look at this. Now it has been retained. These dimensions are retained. The alignment, we can adjust it. If we want to go a little further, we can. This is why joints are far superior to using move and copy. So anyways, let's go back here to -50. That's what we want. You can see we've got this joint right here. This is showing that there is a joint between something and something else. Well, when again we have 100 different components, we want to make sure that we rename our joints properly. So first of all, let's rename this component. We're going to go over here and we're going to call this 75. Let's get rid of the bracketed one. And then we can expand joints. And instead of rigid one, let's go like this. Let's go to helical gear 75 to helical gear 100. Okay, so remember in Fusion, we go this to that. So we clicked on our first component that we wanted to move, and we moved it to that component. So that's why I address our joints the same way. Same type of naming convention is I say this to that. Helical gear 75 to helical gear 100. And this is the scale factor. So it's just a name that I call it. It doesn't have to follow the same name in your workflow, but whatever works. So I'm going to hide that joint right now. So this is looking really, really, really good. So at this point, what do we do? Well, let's create the last profile. So let's go here. We're going to go copy up to our top level component, paste new. Excellent. Let's just move it off into space somewhere. S for search, scale. There we go. Going to pick that. And now we've got this new component. Let's expand its origin. Remember, if we turn on the original origin's way over here. We don't want that. That's kind of our master origin for our entire part. Let's just turn on this origin, which always moves with our part. So let's go point. We're going to pick that right there. We're going to move it down to 0.5. Very good. Excellent. We can hide that origin right now. Go back to joint. Remember this to that, this to that. So let's pick the center point. If we find it a struggle to pick a certain snap point on our part, remember, pick the face. And then our face turns blue and it forces us to pick something on that face. We can pick the center point. Can do the same thing over here, this to that. Perfect. Flip. We're going to move it on over and this is going to go to 100. Perfect. And we're going to rotate this 30 degrees now. So as our drawing says, this is at a scale factor 50 and it's rotated 30 degrees. Perfect. So look at that. We're just going to rename helical gear 100 now. And we're going to call this helical gear 50. And again, this is the profile that we want. Okay, very good. So some have asked, well, what do I use? Do I use bodies or do I use components? Well, in this particular tutorial, you've seen that bodies are limited. We can't use bodies because they don't work in our instance. So we have to create components. And through these three components, we can create, which we're going to do in a moment, we can create a loft between the three of them, which will create the desired profile. Very good. So at this point, I'd like to just teach one other thing. So say, for example, that our design sometimes changes. Sometimes it is not 100 millimeters long, but it's 120. And the middle component here will always be placed at the middle. I just want to make sure that one thing is defined before we go on. I can just click this face and then press Shift and click this face to see the dimension between the two of them. So these two are 50 mils apart. This one and this one are 100 mils apart. So say we always want the middle one to be split right at the middle of these two faces. Well, instead of going in and having to adjust those every single time for every single change in the future, I'm just going to create a parameter. So go to Modify and go down to Parameters, and you can go to this kebab menu over here and pin to toolbar. You can see I've already done it and I've actually pinned it to shortcuts. So I can either click here on my toolbar or I can press S for my shortcut. And look at that, there's parameters right there because I've pinned it over here. So you can pin to shortcuts and every time you press S, those are your design shortcuts right there. Anyways, let's go to parameters. And you can see here, I'm just going to bring my model off to the side. We're going to create some parameters. So let's go plus. And we're going to call this our gear spacing. There we go. And let's just call this 50 mils like that. And I can also create another parameter. I'm going to call this gear angle. Okay, and instead of millimeter, I'm going to go to unit and I'm going to call this degrees and I'm going to say 15 degrees, just like that. Okay, perfect. So now I've created those parameters. And what I'd like to do is go back in time. And remember joints over here? We should have renamed this one. Let's just rename that. We're going to go helical gear 50 to helical gear 100. And those define both of those joints. So let's change this. Let's add the parameters to it. So I'm going to go to the joint. And we can also go down here to the timeline. But this is the whole point of renaming entities or tools. Is I'm going to go right click and we can go edit joint. Remember, it's brought up the dimensions over here. So what I can do is angle. You can see it's a negative degree. So I'm going to go negative, and I'm just going to type in angle for my parameter. And there it comes up, gear angle, 15. And then the distance right here, I'm going to go negative. What is our gear spacing? There we go. Perfect. So let's go OK. And then the second joint, I'm going to go right click, edit joint. We're going to do the same thing. This is really cool. We're going to go negative angle times, we use an asterisk for multiplication, times 2. Perfect. And we're going to go here, negative spacing times 2. There we go. So now we've created this parameter. So instead of going back and adjusting the joints all the time, adjusting the dimensions if we need to, we can go to change parameters. And look at this, as soon as I change this, let's go 75. Look at that, they instantly space. Let's change our angle. So 20, there you go. So you can see this angle is 20 degrees off of this. And this one is 20 degrees off of that, or 40 degrees off the first one. So this is looking really good. Anyways, this is just kind of something to learn with joints and parameters. You can use them together. So sometimes bodies is really good to copy and paste a body, but joints allow you to use parameters and allow you to control your model a lot more. So let's go back to 15 degrees right there, just as our drawing says. Now, just before we move on, we wanted to send a shout out to our sponsor. Let's say that you needed this 3D printed in a high quality material and you don't have a 3D printer. Well, you can head on over to our sponsors page, PCBWay. There you can select all sorts of different types of materials to do 3D printing. You can also get parts like this CNC machined, which is really cool. And if you're interested in a project where something is CNC machined, you can check out our whole series on creating a safety razor. And I'll put a link to that tutorial in the description below as well. Thanks again, PCBWay. Great. So now I'm just going to minimize those right there. And now this is where we create our loft. So let's go to loft and we're going to pick those profiles. So assume that these are sketch profiles. I'm going to pick the first one, second one, and third. So it wants to cut through those 3. We don't want to do that. We want to go to operation. And in fact, I'm going to create a new component at this time. The component doesn't affect the other bodies at all, or the other components. It will create a new one using those 3 planes, and we're going to go OK. Now we can hide those other components over there. Let's say we didn't want them in our browser. Well, we can get rid of them. Let's select all of them. We can pick one at a time by holding down Command or Control on a Windows computer, or we can pick the first, Shift, pick the last, and right click. Now, don't go delete. If we go delete, it's saying that other things downstream will also be deleted. If we go delete, everything's gone. The loft has a warning right now, so this isn't good. Let's go undo. Let's instead go pick all of them and go remove. Now you can see in our timeline, we've got these 3 removed components, and it actually says what's been removed. Very good. So if we ever want to see what's before this in our timeline, we can move our timeline over and we've got our 3 components right there. And again, what we can also do is if we change a parameter, even though we've removed those components, the parameters will still adjust our new component. So there we go, 60. We can adjust the angle over here, 20 degrees. So here, as we change it, just press enter. We don't have to go OK and then readjust and readjust. Just press enter. Let's go back to 15. There we go. Our model's now adjusted and we've removed those components. So in this instance, I don't want to remove them. I just want to keep my browser so that I can go back and adjust those if need be. So I'm just going to delete those, and there they come back. I just want to hide them instead. Very good. Now we've got our component number 5. I'm going to rename this to our helical gear, because this is the official helical gear. It doesn't matter. We're not talking about any scale ratio or anything like that. Great. So now we're going to work with this helical gear. I want to activate it. So there we hover over it. We're going to activate it. So this is solely being worked on. And look at the timeline. It goes down just to the first tool as part of this component, which is the loft. Very good. Okay, so let's go to circular pattern, and we can go to bodies. We don't want to create several components at this time. We just want to pattern this body. So let's pick that. Let's pick our axis is going to be our X axis right here. And this is supposed to have 6 teeth as the drawing says. And let's go OK. So now if we expand helical gear, we've got 6 bodies. Now, my computer just went a little slow, so I'm going to make sure to save it. Save often in Fusion. Save often in Fusion. It will save a lot of heartache. Okay, so we've got these 6 bodies, but now we want to join them together. So how do we do that? Let's go combine. We pick our target body, which is the body that we definitely want to keep. And in this instance, I want to keep the original body 1. And then tool bodies, I can pick 2, 3, 4, 5, 6. And we don't want to pick anything else. We just want to keep join, and we're going to go OK. So now it's created one body, all those different features together, and it's still completely parametric. Let's activate our top level component. I guess we didn't really need to do that, but let's just bring our model over. We can change this, and look what happens. 60, you can see everything is still fully parametric. It's looking really, really, really good. So let's go 15 right there. Okay, perfect. So let's pick that and this face, and you can see it's 100 mils, which is perfect according to our drawing. Okay, let's activate our helical gear one more time. Remember, it brings down our timeline, so just the tools that we're using to create this particular helical gear. And now I'd like to create the rest of the shaft over here for the gear. So let's go to create, and I'm going to create a sketch for this. And you might be tempted to create the sketch off of this face and build it backwards in X. But what I'm going to do, we're going to do Revolve right now. I'm going to pick the XZ plane. And what I'm going to do is let's create all of our sketch features coming off in this direction and then revolve it all together. So this is going to be 170 mils. I'm going to keep it at 0 degrees. If you don't see this symbol, it means that your line is not constrained and it can move up and down. So I want to make sure that this is 0 degrees or horizontal, and we can pick this constraint and just snap to our line. And again, you can see I've pressed escape to get rid of any background tasks. Now let's do this here. This is where we're going to use diameter dimension. So I'm going to move, just create a couple of the dimensions to start. I could create all of them, but sometimes that creates confusion as well, and sometimes the lines go all over the place. So let's just start one at a time. I'm going to go D for dimension. I'm going to pick the center line first, and then this dimension right there. Move it on over, right click, diameter dimension. And now, just like our drawing shows, we can work with a diameter value instead of a radius value. So there we go, 60 mil. And you can see that it's creating this imaginary line down at the bottom, and this is reflecting what the total diameter is. So this is looking really, really good. Now let's create this length right here. Very good, 30. And now we can just keep on moving along. Let's do that. So let's pick our center line, this one, right click, diameter dimension, 82. Very good. And we're just going to keep on going along over here. Now this is kind of a little secret right here. I'm just going to zoom on in. And we're going to, why don't we just create the rest of our shape. There we go. So here at the very end, this line actually, because we snapped it to this point, it doesn't really snap to our gear. And the reason is because it's snapping to the grid line instead. So I want to make sure that this point is exactly vertical to this point. So how do we do it? Remember, press escape to get rid of any background tasks going on. Horizontal, vertical. I want to say that this point is vertical to that point. Very good. Now let's create a line between those two. And let's just put in our diameter, rest of our diameter values right now. So again, D for dimension, center line first. We're going to pick that. Right click before we left click. We're going to go diameter dimension. And this is going to be 65. Very good. The way that I position my dimensions is standard practices try not to overlap any dimensions. So I'm just going to single click and drag them. I can move it over there. Very good. Let's just keep on going down the list. Diameter dimension, 86. And here to there, right click, diameter dimension. And this is going to be 96. Perfect. Now we just have to put in our Z values as well. So D from there to there. And that's going to be 80. Very good. And I'll just go a little bit fast here to speed up this tutorial. Actually, before we move on, you might be wondering, why am I picking the line rather than a point? Well, let me show you. If I go D for dimension and I go point to point, it actually will create, it will give me an option between creating, a dimension, an angled dimension or a vertical dimension or a horizontal dimension. And that's because it's going point to point. But if I go line to line, it's going to force the dimension to always be left and right. I can't do an angled dimension. I can't do a vertical dimension because it's going to be perpendicular to our two lines that I've picked. So remember, it matters what you pick. And you get used to that. You'll start, as you keep learning Fusion, that will make more and more sense to you. So anyways, there we go. We've got all of our basic dimensions. Now I need to also create this circle right here, the circular groove. So I'm going to create a circle, and I'm not going to worry about trimming it. And I'll show you why in a moment. Let's first of all make this circle tangent to this line. And you can see the center is constrained to this line right there. If it's not, you won't see this symbol if you click the center point. I'm just going to delete that symbol. And now you can see that the center point is movable, but the circle is still tangent to this line. So I want to constrain this point to that line. And all I'm going to do is go coincident. I'm going to pick that and that. You can see it constrains it together. Now let me show you one other thing. This frustrates people. Look at, I've just moved this midpoint and look at the point. It's blue right now. That means it's selected in the background. And that's why we press escape to get rid of background tools or tasks. But in this case, let's assume that I have picked the circle. It's blue. I can go coincident and I'm just going to pick that line and it will snap. So anyways, it's a whole lot easier when you realize what Fusion is doing and how to work with it. And you don't have to fight it so much. Let's press D for dimension. We're going to create a radius value to this. So as soon as I pick a circle, it assumes that we want to use diameter. I don't want to use diameter. I want to use radius. So again, we're going to right click and we can select radius. There we go. So radius of 8. And now the circle is fully constrained. This is why we don't trim. If I go trim and I start trimming this right there, oh, in this particular instance, it worked. Let me go back in time. There we go. Let's trim this right here. Oh, that worked as well. Sometimes if you use trim, it ends up deleting some of your constraints or some of your dimensions. I'm just going to show you that we don't need to trim. And if you pick this close profile, look at everything blue is what you want to revolve. So just keep these profiles. It doesn't matter. This blue close profile is what we're going to revolve in the end. Now, one last thing is we're going to talk about chamfers and fillets before we move on. So would we add our chamfers and fillets at this point? Well, no. And the reason is because it's far easier to create fillets and chamfers in a 3D environment, 3D modeling environment, rather than in your sketch. And sometimes in your sketch, it breaks your constraints or your geometry or your dimensions. So don't put in your fillets and your chamfers at this point. Wait until you've created a 3D model first. It also saves a lot of stress on your eyes trying to find all these different dimensions, especially if we had 100 different chamfers. Oh, it's really hard to view what's actually going on. So anyways, we've got all this. I'm just going to straighten out my dimensions a little bit more, make it look pretty. And I also want to verify that I have all the dimensions on my drawing. Now, just so you know, my workflow that I used to do in the shop that I worked for is, as I was designing, I would highlight each dimension on my drawing, and then I'd go back and double check, and I would check off those highlighted dimensions. The reason is sometimes it's very easy to forget a dimension even though you've highlighted it. And in the manufacturing world, if you forget a dimension and you run 1,000 pieces, 10,000 pieces, 50,000 pieces, and then you realize at the end you've missed a dimension, well, whose fault is that going to be? So I double check, measure twice, cut once is the principle, and that's what I end up doing. So here we go. We've finished all our dimensions. Now let's revolve it. Create. We're going to go revolve, and we can pick this profile axis. We're going to pick this center axis right there. And look at that. We've got this beautiful profile right there. Okay, and as soon as we create the revolved 3D model, the 3D body over here, well, you can see it gets rid of our sketch, which is exactly what we want. And also within our revolve, we want the operation to be join, and it will join it to the helical body. Now it's creating one body for us, which is great. Okay, so the last thing that we're going to do before we put on our chamfers and our fillets and everything is we're going to create the cutouts for our gear. And you know what? On second thought, actually, we're going to put our chamfers and our fillets in right now. We usually save it to the very end if they're small. In the case of this, it's kind of part of our main profile, so we want to keep this. But I was thinking what we could do is do the gear first and then add all the chamfers after that. But that's going to take a while to select all those individual chamfers around there. Anyways, let's put it in right now. So let's go chamfer, and we can pick 1, 2, 3, 4, 5. And those 4 actually are, oh, we have one more. So these 5 right here are all going to be 1 mil. And then the one at the front is a different size. So instead of creating, going okay and then creating another chamfer tool for this and calling that 2 and going okay, what it does is it adds 2 tools to our timeline. Let's just delete that one. We're going to go back to our chamfer. We want to keep our timeline as short as possible. So let's add a selection set. And now we can create a different size chamfer at the front. And you can see we've got 5 edges over here. 1 edge. If we ever want to add another edge, just hold Command on a Mac or Control on a Windows computer, and they'll all turn back to their blue lines. If you let them go, they show the complete chamfer. But if you hold it down, you can pick other lines as well. There we go. So we're going to go OK. And now let's go to Modify. We're going to create a fillet, and we're going to create a fillet for these inside edges right there. 1, 2, 3. And that's going to be 1 mil. Okay, perfect. Let's go OK. Now we're going to create a sketch on this profile right there. Make sure it's oriented so that up is up. Now you can see this is a little bit challenging to see everything because we're looking at this complete model over here. So what I want to do is hide the body. You can see that the face that I picked is retained on our sketch. So you can see it's basically, we're working with these 2 elements. This is the top of our fillet. This is one other reason why we usually don't create a fillet before we finish our sketch is if in the future we delete the fillet, then sometimes this sketch, even though we've created the sketch on this profile, there might be some warnings. So generally we save fillets and chamfers to the very end. But in this case, let's create our dimensions, and we can actually pick, remember, because I created a sketch on that face, it's inherited these dimensions. It's kind of hard to see, but that's all right. Train your eyes to see it. I'm going to create a center line over here. I'm going to create another one. Make sure all of your endpoints are black. That means that they are constrained to that particular entity. And if you're unsure, you can always click on it. And if it has the symbol, it means that it is coincident to something else. The one thing that is off though is our blue lines. We can click and drag them. So let's create a symmetry constraint. I'm going to pick those two lines, our center line right there. And in fact, do I want to turn that into a construction line? Yeah, let's turn that into a construction line. Very good. So what we can do at this point is let's put the dimension over here, which is 10. Very good. And here we can pattern it all the way around. What I'd like to do is, yeah, let's go pattern. We're going to go circular pattern, and I'm going to pick that object and this object and our center point right there. So here, let's go to, and I believe we have 12 of them. There we go. Let's put in our quantity of 12. Okay. You can see they're all constrained as well. And we're going to create a line in between there and there. Okay, because this line, we have to make sure that it's the right dimension. Let's press D and click from there to there. If I click, you can see, do we want an over-constrained sketch? No, we want to create driven. This is just a reference diameter, and this is supposed to be 36. This is supposed to be 36, so this is the wrong dimension. Let's delete that. So what we actually have to do is delete this line right there. Do you know what we can do? Yeah, just to make it easier on us, let's go back in time. We can create that line. We can create another line from there to there, and we actually want these two lines to be parallel with each other. Now this line right here is what we want to dimension or constrain. So this is going to be our 36 mil as our drawing says. So that looks really good. Now what we can do, instead of going all the way around and creating that dimension for every one of these gears, we can just use what we have right here. So let's make our body visible again. We can go to Extrude, and you can see now we have another limitation. We're trying to work with this chamfer right here. And if I click on that and I extrude, you can see it's not extruding our chamfer. So let's just go back in time. We're going to go back to our drawing. And what I'm going to do is press P for project. And what it does is, remember, we've selected this face as our sketch, but I want to bring over this diameter. As I hover over the diameter, you can see that we've got this red line that is a reference to this diameter. We could also pick this edge right there, but we can pick either one, surface or an edge. If I select on it, it's going to create this now purple line. So if we hover over it, it's red. As soon as we click it, it turns purple. Now we've got this reference that we can work with. So let's hide the body again. And now we just need to extend these lines up to there. So in fact, let's go to modify. We can go extend and then pick those lines right there. Now we can extend that as well. Why not? Very good. You can see everything else is now not good anymore. All these other lines are no longer constrained. So let's go back. Let's go back here. That's fine. And what we can do is just to simplify everything, I'm going to go to this pattern and I'm just going to go to, yeah, let's keep that at 12. Let's keep that at 12. So I'm going to create another line. Let's just do this. This is going to be a whole lot easier. I'm going to create a line from there to there. Now you can see my sketch is getting a little sloppy. And again, it's kind of based on this chamfer that I have right there. If I never created that chamfer, well, then it wouldn't be doing what you see right now on your screen. So there's a little bit of bittersweet when we're creating a drawing. And this is one thing. In fact, let's try something else here just to show you. Instead of creating this projected geometry, I'm going to go finish sketch, and instead of this chamfer, let's say that I wanted to just leave the chamfer to the very end. So I'm going to grab this sketch and I'm going to drag it before the chamfer. Now, and everything's broken at this point. Yeah, these are no longer linked to anything. But we could easily fix this. Let's go to coincident. Let's go coincident, and I can just connect those lines. I can connect that to that, and then this should solve it. Yeah, this is a whole lot better looking right there. and Y. There we go. Yeah, I've got to go coincident, pick that endpoint. It's forcing me to pick the line. I want the endpoint coincident to that. There we go. Now everything is constrained. Everything's looking good. This is still good, good, good. Perfect. And now what we want to do is we could put, yeah, the chamfer and the fillet on there, but our sketch is still the entire profile, which is looking really, really good. So let's do that way instead. We're going to pick that profile. We're going to go to an object. We can go right there. Perfect. So even though I've sketched all these, don't worry about having to create a sketch for every single one of those. It would take too long. We can just create this one extrude, and we can go back to our circular pattern and go to features as our object type. And let's pick this extrude. You can see it selects that extrude, and our axis, we can pick any axis point. We could even turn on our origin and pick our x-axis as well over here. But we can pick any part of our cylinder, and we can do the same thing. Let's say we want 12. Perfect. We can also verify that it's right in line with our sketching. Perfect, just like that. So very easily, we've created this model. Now, before you go, we want to know how long did it take you to make this model. Please drop a comment in the comment section below for how long it has taken you, and any problems that have arisen along the way, please put those in the comment section below. Remember, again, you can head on over to our Patreon page to get the entire drawing. It's actually available for both Patreon members and our YouTube members. And speaking of YouTube members and Patreon members, I'd like to send out a shout out for everyone who has supported us. Thank you so much for your generous support. We really appreciate it. If you've benefited at all from this tutorial, if you've learned something new, please drop a like below. If you love our channel, please subscribe. It means a lot to us. And until next time, hope you enjoy our other tutorials and hope you keep on learning with the Learn It channel.